Once again, good morning and welcome to our math class today. Today, let's talk about the last topic for chapter 4, and it's about solving radical equations. Now, let's start with today's memory verse. It's found in Luke 6, verse 27, and still it's about radical love. It says, "But love your enemies and do good and lend, expecting nothing in return, and your reward will be great, and you will be sons of the Most High, for he is kind to the ungrateful and the evil." At the end of today's class, you will answer our MVCA boosters, and it's about Jesus, an exemplar of radical love. If you say exemplar, it means an example of doing radical love. Jesus is a perfect example of someone who showed radical love. List 3 events where Jesus showed radical love. So that will be your MVCA boosters for today. At the end of today's lesson, you'll be able to do 2 things. First, solve equations using radical expressions. And the last one will be solving problems involving radicals. And here's your venture activity. It's about the Egyptian rope structures. Now, what is this all about? Ancient civilizations were concerned because you see, before they need to make right triangles. And a right triangle needs to have right angles, but they didn't have specific measuring device before. So why do they use right angles? They need to have right angles if they need to construct a building. Remember, the wall must be a right angle with the floor so that it won't collapse easily. Or when they survey, they need to have right angles. Now, how did they measure right angles? They make use of rope stretchers. A rope stretcher is a rope stretched to form 3, 4, 5 right triangle. Now, how do they do the rope stretchers? They place 12 equally spaced knots in a rope, because if you will add this one, 3 plus 4, that's 7, plus 5, that's 12. So they need to make 12 equally spaced knots. And after that one, they need to divide it. The first one here, the first leg will get 3. The second leg will get 4. And this one, the hypotenuse, will get 5. By that, they are now forming a right angle or a right triangle. Now, how can we apply it in radicals? In radicals, we also solve for this one, the area or the measurement of the size of a right triangle. And this idea is the origin of that. Now, what is a radical equation? A radical equation is an equation in which a variable, again, the variable is a radicand. For example, if we'll have the first one, you just check on the radicand. On the first one, the radicand is x. Therefore, it's a radical equation. The second one, the radicand is still x. For the third, the radicand is x plus 2. There is a variable. In the last one, the radicand is x squared minus 3x minus 6. You see, there are variables in your radicand plus an equal sign. So we call these radical equations. Now, how to solve radical equations? Let's have some properties. The first property is, if A is equal to B, then a to the power of n is equal to b to the power of n. Example, if we have x is equal to 5, then if we square the x, we also square the other 5. So these two are still equal. Now, how to solve radical equations? Ready? Number 1, step 1. You isolate the radical on one side of the equation. It means the left side can be a radical, the right side can be a non-radical. Next, step number 2. In step number 2, we apply the power property of equality. What exponent do we raise it? It depends on the index. Example. Now, in the chat box, can you tell me what is the index of the left-hand side? In the chat box, please. Can you tell me what is the index? Very good, Jared. The index is 2. So since the index is 2, then we raise both sides of the equation to the power of 2. So raise the power of 2, and to the right-hand side, raise to the power of 2. That's how you do it. Next, step number 3. We find the roots of the equation, or we solve the equation, the variable. And step number 4, this is very important. We need to substitute the value to the original equation to check if there is a solution. Now, ma'am, what if after solving x is equal to 4, but when I substituted it, the equation is wrong? Then we say there is no solution. And 4, which is solved a while ago, is called extraneous solution. The root word, extra solution. It's a solution, but it's an extra. It's not a part of the real solution. So now let's start with the first one. Ready? Let me first start by doing this one. Remember, the left-hand side is a radical. The right-hand side is just a number. Now, in the chat box, can you tell me what's the index? What is the index? Very good. The index is 2 because there's nothing written. With that one, we raise both sides to the power of 2. So raise to the power of 2 on the right and raise to the power of 2 on the left. Remember, when the index and the power are the same, we cancel them. So you just copy the radicand, x plus 2. Next, 3 squared is equal to 9. The next step is we need to solve for the value of x. We transfer 2 to the other side. We have 9 minus 2. The positive becomes negative. So the value of our x is 7. Now, step number 4 is to substitute 7 to the real equation. So let us now substitute. Or in your elementary years, we call it checking or verifying whether the answer is correct. So square root, our x is 7 plus 2 equals 3. We work on the left-hand side. 7 plus 2 is 9. Square root of 9, that's 3, equals 3. Therefore, it's correct. So 7 is a solution to the given problem. Any questions? No other questions? Yes.
Ma'am, so So it's all dependent by the index number?
Yes, you need to check the index. Whatever the index is, that will also be your exponent.
So I distribute the index to the others, then move 2 to 9, which becomes -2. Then a minus?
No. We don't distribute the index. The index and the exponent will be the one that will be canceled. I'm not distributing any. Example, another example. 4th root of x equals 2. What is now the index? What's the index?
Index is 4.
4, very good. Since the index is 4, then it means that we raise both sides to the power of 4 and the other side to the power of 4. Since the index and the exponent are the same, then we cancel the radical sign. So what's left is only x. No more radical sign. Then 2 to the power of 4, that's 2, 4, 8, 16. So the answer is
16.
X equals 16. That's it. Okay now, AP?
Thank you, ma'am.
You're welcome. Now let's go to the next one. Ready? This one. Now, can you tell me in the chat box, what is the index? What is the index?
X.
It's not x. You look at the radical sign. The index is still 2. Very good. So, since the index is 2, we raise both sides to 2. Next, the index and the exponent are the same. So the radical sign will be canceled. Let's go to the left side. X squared is x squared. Since the radical side is now canceled, we copy the one inside. Then we start combining like terms. 0 on the left side, x squared, transfer this one, minus x squared, minus 3x, minus 6. Wait first. Okay, so this is now 0. We now have negative 3x minus 6 equals 0. Let's transfer 3x to the other side. So 3x equals negative 6. Divide both by 3, the numerical coefficients, cancel it. So x is equal to negative 2. Now, let us substitute it. Ready? 2. Negative 2 squared. That's x, not squared. No more squared. Equals the square root of negative 2 squared. That's x squared minus 3 times negative 2 minus 6. So we now have negative 2 equals, negative 2 squared is 4. Negative 3 times negative 2 is positive 6 minus 6. Next, 6 minus 6 is 0. So square root of 4 equals negative 2. Remember what's the square root of 4? It can be plus or minus 2. So they are just the same. One answer will do. Therefore, negative 2 is a solution to the equation. Any questions? Or give me a thumbs up if you're already okay with that. Okay, let's now go to the third one. Remember step number 1. A radical on one side and the rest you transfer it to the other side. So with that one, we transfer 5 to the other side since it's not a radical sign. So we now have -2 square root of x equals 2. Then transfer 5, it will be -5. So we now have -3. That's 2 minus 5. And on the left side, we will have -2 square root of x. Next, we need to leave the radical sign alone. So if there is a number before the radical sign, then we need to divide both sides by that number. So the number is -2, so divide both sides by -2. Now cancel it. What's left is the radical. So square root of x, -3 divided by -2 is 3/2. Next. We now have the radical on one side and the number on the right side. So we raise both sides by the index. What's the index? You could not see, right? So we know it's 2. So raise both sides to the power of 2. Since the index and the exponent are the same, then the radical sign is now canceled. We have x equals, okay, this one, 3 squared is 9 over 2 squared is 4. So our answer is 9/4. But step 4 reminds us to substitute our answer or to verify. So let's substitute 9/4 to the value of x. Here, we substitute 9/4 to the value of x. So we now have 5 minus 2 square root of 9/4 equals 2. What's the square root of 9/4? It is square root of 9 is 3. Square root of 4 is 2. There. Same numerator and denominator. You can cancel it. So 5 minus 3 equals 2. Let's simplify the left side. 5 minus 3 is 2 equals 2. Therefore, 9/4 is a solution. Any questions? Feel free to raise your hand. Okay? I'll continue discussing, and if you have questions, feel free to raise your hand. Okay? Give me a thumbs up if you're ready to go to the next example. Oh, yes, AP, you're raising your hand.
Ma'am, how do we know if it's a solution? Like it's 2 equals 2?
Yes. If in verifying, remember this is step number 4, verifying part. Once you verify and the end answers are equal, then it's a solution. But for example,
okay,
the end answer is 1 is equal to 2. It's not the same. So it's not a solution. Okay. Wait.
Okay, thank you, ma'am.
Sorry, my eye is so itchy. Okay, let's go to the next one. Ready? Here. Remember step number 1? Step number 1 reminds us that you need to transfer non-radicals to the other side. So we transfer them. Wait first. Okay, there. We transfer 4 to the other side. So what's left is a radical a minus 2 equals, on the other side is a minus 4. Now, we have a radical on the left side and the index is not written. So we know that the index is 2. So we raise the left-hand side to 2 and we also raise the right-hand side to 2. The index and the exponent are the same. So the radical sign is now canceled. What's left? A minus 2. But here, you need to expand this. And how to do that? That's a minus 4 times a minus 4. Or if you apply your special products in grade 8, it is just the square of the first minus twice the first and the last plus the square of the last. So we now have a squared minus 8a plus 16. Let's copy it. A squared minus 8a plus 16. Then we combine like terms. We now have a quadratic, right? So we make it positive. Let's transfer the rest to the other side. I'm not distributing, I'm transferring. Or we say transposition. So a squared minus 8a, transfer a, negative a. Plus 16, transfer negative 2, we have negative positive 2, plus 0. Let's combine like terms. We have a squared minus 9a plus 18 equals 0. Okay, now what's next? Here's where you will apply what you learned in chapters 1 and 2 in quadratic equations in solving for the value of a. Remember, there are 4 types. You can extract the square, you can do factoring, you can do completing the square, or using the quadratic formula. So you just choose. Now, for example, in my case, I'll do factoring. Let's continue here at this side. So for a, that's 1 and 1. For 18, that can be negative 6 and negative 3. Cross multiply, negative 3, negative 6. The sum is negative 9. So it's the same, right? The factors are a minus 6 times a minus 3 equals 0. That's why you need to remember to recall again what you learned in chapters 1 and 2. Let's solve. Ready? A minus 6 equals 0. A equals 6. What's the other? A minus 3 equals 0. A equals 3. Now, there are 2 answers. Let us check if both answers are correct or if only one is a solution or nothing. So let's verify. Happen. Let's start with 6, okay? For A equals 6. 4 plus 6 minus 2 equals 6. 6 minus 2 is 4, and the square root of 4 is 2, right? So 4 plus 2 is 6, sorry, what's happening? 6 is equal to 6. Therefore, the first one is a solution. Let's check the second one, 3. I'll try writing on the other side if it will work. 4 plus 3 minus 2 equals 3. You now have 4. This is 1 equals 3. 5 is equal to 3. Now, is 5 equal to 3? No, right? Therefore, 3 is not a solution. So what will be our final answer? Our final answer is A is equal, what's happening to this? A is equal to 6. Now, do you have any questions before I go to the next one? Or if you don't have questions, feel free to give me a thumbs up. Okay, very good. Let's have the last one first before we will go out and get back again. These two are just the same. Let me check first the others. It's different. Okay, let me have this one. Okay, now in the chat box, can you tell me what will we do first? In the chat box, can you tell me what will we do first? That's 3 square root of 6x minus 5 equals negative 15. What should we do first? Move 3 to the other side. But let me clarify, Jared. You only move 3 to the other side if it looks like this. 3 plus square root of 6x. Like that one. If this is how it looks like, you move 3 to the other side. But here, it's a product, right? So what will you do? Other answers. What will you do? We will? Very good. We divide both sides by 3. Here, when do we transfer? If there is a plus or minus sign in between them, that's when we transfer. But here, it's only one expression. It's multiplication. So we divide both sides by 3. Very good, Ali. So with that one, we cancel this. So we have 6x minus 5 equals negative 5. Next, we square both sides since the index is 2. Since the index and the exponent are the same, we cancel the radical sign. So we have 6x minus 5 equals 25. Next, we transfer negative 5 to the other side. So 6x equals 25, and negative 5 becomes plus 5, positive 5. So 6x equals, you add this to 30. We divide both sides by 6. So x is equal to 5. Next, we verify. Is the answer correct? Let us see. Now to verify, we have 3 square root of 6 times 5 minus 5 equals negative 15. So 3, this is 30 minus 5. That's 25, right? Negative 15. What's the square root of 25? It can be positive 5 or it can be negative 5. Since our answer is negative here, then I suggest you write the negative 5. Now, our left-hand side, 3 times negative 5 is negative 15 is equal to the right-hand side. Therefore, this is a solution. Any questions? Or give me a thumbs up.